In this video, I'd like to deal with solving fractional equations, and more importantly, I want to talk about how we can deal with a bunch of fractions in an equation and make life a little bit easier. So instead of dealing with all those fractions, talk about a way we can eliminate those and then solve the equation with integers. So as a review, up till now we've solved equations, and the main thing we've been doing is applying inverse operations in order to solve an equation, and we do this in the opposite or the reverse of the order of operations. We've also solved equations by combining like terms together. So if we have multiple variables like 2x and 3x, we've combined those into 5x. And then also we saw sometimes where we had to use our distribution property and distribute across parentheses in order to combine like terms and then solve. Today what I want to look at is solving equations with multiple fractions. Now we've dealt with adding and subtracting and multiplying fractions in the past, but with an equation like this, it can be very tedious to go all the way through, constantly finding common denominators in order to add and subtract, and constantly multiplying fractions, getting new denominators, and then trying to find common denominators for those all over again. So instead, we can ask ourselves, well, wouldn't it be nice if we could just get rid of all these fractions and then just solve equations just like we've been doing for the past few classes now? And luckily, the answer is yes. We actually can clear or eliminate fractions from an equation, and the way we do this is by multiplying both sides by the least common multiple, which we've reviewed in the past. What this is going to do is create fractions that can all be reduced to integers, and then we can just simply solve that equation without having to deal with all of the fractions. So as a quick review, a least common multiple is the smallest whole number that is a multiple of two given values, or even three given values, or four given values. So as a quick refresher, I can say that if I gave you 6 and 8, well, I know 24 is the least common multiple because 6 times 4 is 24, 8 times 3 is 24. Both of those can be multiplied and evenly divide 24, and there is no number smaller than 24 that works for both of these. And then same idea, 6 and 20, the least common multiple is 60, because both of those can be multiplied 6 times 5 and 20 times 3 in order to make this least common multiple. So in our first example, we're asked to solve for x, and I see that I have 4 different fractions, and I have 3 different denominators. So first I can see that I have this denominator of 3. I have a second denominator of 2, and then I even have this third denominator of 6. And our goal is, well, wouldn't it be nice if we could get rid of all of these different fractions and just have integers? So what I'm going to do is look at 3, 2, and 6, and I want to look for the least common multiple. And the answer is, of course, 6, because 3 times 2 is 6, 2 times 3 is 6, and 6 times 1 is 6. So my claim is that if we multiply both sides by the least common multiple of 6, we should be able to actually simplify. So let's see. I'm going to put both sides of these equations in brackets or parentheses. Doesn't really matter. But we just want to recognize that we are going to have to multiply the entire side of the equation. So I'm going to first multiply by 6 on the left, and then 6 on the right. And we want to see here, I'll clean up the 6 on the right, we want to see if this is in fact going to get rid of the denominators. So, as we talked about last time, this is our distributive property. I'm going to multiply the 6 through to both terms on both sides of the equation. Now you might be asking, well, what about the denominator? Well, don't forget, this 6 is being divided by a 1. Right, so I am technically distributing that 1 in the denominator, but multiplying by 1 doesn't do anything. So on the left-hand side, I first multiply through 6 over 1 times 2 over 3. That's going to give me 12 over 3x. 6 times the 4 gives me a 24 over 3. And then on the right-hand side, if I distribute, I get 18 over 2. And then 6 times 1 is 6 over 6x. Now, the whole point of this, you might be saying, well, hold on now. All I have are bigger numbers and fractions. That didn't help at all. But the goal is that now if I look at these fractions, every single one of these fractions should now simplify, or in other words, divide down to an integer. So let's look at our first fraction. I notice that 12 over 3 here simplifies straight down to 4 because 12 divided by 3 is 4. Similarly, I can look at 24 over 3, and I know that 24 divided by 3 is just 8. I know that 18 divided by 2 is 9, and that 6 divided by 6 is 1x. And right off we can see, well, isn't that a lot nicer? As a result of multiplying by a least common multiple, all of these different numbers now are much easier to work with, and now we can just do basic combining of like terms and then solving. So first, I notice I have some common variables here, 4x and 1x. They are on opposite sides of the equation, but I'm going to notice that it really doesn't matter what I do, I just have to combine them somehow. But I need to bring them onto the same side of the equation before I can combine them. So I'm going to move to the smaller one. I'm going to subtract the 1x. Notice I'm applying an inverse operation here. I'm going to subtract 1x from both sides, and I notice that this is then going to give me this new equation, 3x minus 8 equals 9. And notice how these last two terms here, 1x and negative 1x, just add to 0. So again, we notice I used an inverse operation on both sides of the equation in order to move the common terms to the same side, and then I was able to combine those like terms of 4x and negative 1x into 3x. So now I'm just going to continue with this equation. In order to have some more room, I'll rewrite it here on this right side of the equation, on the right side of the board rather. So we are left with 3x minus 8 equals 9. And I've combined my like terms, there's only one variable. All I have to do now is solve this equation. So we're back to the basics of solving linear equations. I want to do inverse operations in the opposite of the order of operations. So I have two operations, multiplication and subtraction. Since we're doing the opposite of the order of operations, the first thing I need to get rid of is that subtraction. So I'm going to draw a line down the middle of our equation. I'm going to add 8 to both sides since that's the inverse of subtraction. And this is going to leave me with 3x equal to 17. And now that we're all by ourselves, all I need to do is apply the inverse of multiplication. Notice how 3 and x are being multiplied. The inverse of multiplication is division, so I divide both sides by 3. And we're left with our solution, which is x equals 17 over 3. In our second example, we see again that we have even more fractions this time, a total of 4 fractions that we have to deal with. So again, I'm going to first look at, well, how can I get rid of these fractions? And again, we want to look at the denominators. 10, 3, 6, 5, and there's actually nothing under the x, but I can always imagine that there's a 1 there if I want. And here are all my denominators. So I'm asking, well, what number can 10, 3, 6, 5, and 1 all evenly divide? Or in other words, what can I multiply all these numbers by and somehow get the same multiple? And the answer is 30. If I look, I can multiply 10 by 3, 3 times 10, 6 times 5, 5 times 6, and of course 1 times 30. So now that I've identified 30 as our least common multiple, I just need to go ahead and multiply both sides of the equation by this number. Now as we're doing this, you might be worried, well, what if I can't necessarily find the least common multiple? You know, maybe you're confident you found something that is a multiple, but you're not sure it's the least one. That's okay. As long as you find a multiple of all the numbers, you might have to do a little bit more simplifying, but it's still a good place to start. So I'm going to multiply by 30, which we found to be our least common multiple. So 30 on the left and 30 on the right. Okay, so remember, we do have to distribute through. So I'm going to multiply 30 through to all 3 terms on the left and to both terms on the right. And again, don't forget that x is technically over 1, and these 30s even are technically over 1. So really all we're doing is multiplying the numerators. So multiplying through, 30 times 3, that gives me 90 over 10 times x. 30 times 7 is 210 over 3. 30 times 5 is 150 over 6. And then on the right side, 30 times 7 again is 210 over 5. And then 30 over 1x. Okay, now some of these numbers are pretty big, and that's okay if you might need a calculator to actually simplify. But the good news is that because we used the least common multiple, all of these numbers should now in fact simplify down to a single integer. So let's see, 90 over 10, I know that divides to 9. 210 over 3, I know divides to 70. 150 over 6, we can do a little bit of math here. I know 120 over 6 would be 20, and then I need 5 more, so it turns out that 150 over 6 is 25. And again, if you need to use a calculator for that calculation, that's perfectly okay. 210 over 5 is going to be 42, and we still have 30 when I divide it by 1, so over here that's 30x. Good. So again, now we want to combine our like terms, and looking at our like terms, I see a few options here. First, I see these negative 30x and the 9x. I always like to try to get rid of negatives if I can, so I'm going to use the inverse of subtraction and add 30x to both sides of the equation. So that's going to leave us then, I'll put a new line here. That's going to give us 30 plus 9x, which is 39x. At this point, if I want, I can even combine these like terms, 70 and negative 25. That'll give me 45. And I find that this is equal to 42. Good. So at this point, we're almost done. I'll block out a little spot up here in the upper right-hand corner to finish this problem off. I notice that I have left over 39x plus 45 equals 42. And we're just solving this equation by the opposite of the order of operations. So I'm just going to apply these operations. Again, starting, I want to eliminate any addition and subtraction I see by the opposite order of operations. So I'm going to subtract 45, which is the inverse of the addition I see there. And that's going to leave me here with 39x equal to a negative 3. And then finally, I just need to do the inverse of the multiplication, which is division, divided by 39. And then here's going to be my solution. X equals negative 3 over 39, or I can simplify this even to negative 1 over 13 if I divide both of those by 3. And there's our solution. In our third example, again, we want to solve for x, but I actually notice that there's an extra step here, or at least an extra problem. I have these two sets of parentheses, but we actually learned how to deal with these last time. My suggestion is just to distribute right through in the beginning, and then we can immediately deal with the fractions after we distribute through. Multiplying fractions is not too much of an issue here. We don't have to worry about common denominators. So after we do this distribution, we should be able to then deal with the rest of the fractions, just like in the last couple problems. So distributing through, I get 2 times 3 is 6, over 7 times 4, which is 28, minus 2 times 1 is 2, and 7 times 2 is 14, and that's x, minus 5 over 2 times x. Again, we can imagine that there's a 1 in front of this x, so I'm just going to call that 5 over 2x. Then I'm going to distribute the negative 5 over 2 times the positive 5 over 7. And this is a place where it's easy to make a mistake. We're still multiplying this whole term of negative 5 over 2 through. So a negative times a positive, that's going to even make this second term negative 25 over 14. So again, to emphasize that, we're multiplying through by that negative, and since both terms inside were positive, negative times the positive turns both of these new terms into negative terms. Easy to miss that, so make sure you pay attention to that. And then this is going to be equal to, on this other side here, simply 9 over 14 still. Okay. So now, again, the instinct sometimes is just to multiply through by the least common multiple of the denominators we see right off. But a lot of times when we've done something like this, I want to see if the fractions can be reduced, or in other words, simplified. And I actually see two fractions here, 6 over 28 and 2 over 14. I can reduce 6 over 28 to 3 over 14 by dividing both those numbers by 2. And then the 2 over 14 rather can become 1 over 7 by dividing both those by 2. And unfortunately, the 5 over 2, the 25 over 14, and the 9 over 14 are all as reduced as possible. So at this point, now that we have reduced fractions, I can see that the denominator of 14, 7, 2, 14, and 14. And I'm asking, well, what is the least common multiple of 14, 7, and 2? And that is, in fact, 14. So I want to multiply both sides by 14 here on the left. And then also I'm going to multiply by 14 on the right. And again, you can also remember that these are 14s over 1, as that helps you multiply through those denominators. And I am going to distribute through to all of the terms here. So notice how I'm distributing the 14 over 1 to all 4 terms on the left, and then to that 9 on the right. So if we multiply through, 14 times 3 is 42 over 14 minus 14 over 7. Minus 14 times 5, which is 70 over 2, minus the 25 times the 14, which turns out to be 350 over 14, and the 9 times the 14, which ends up being 126 over 14. Okay, so now coming over here to finish up our problem, when we multiplied, first of all, we multiplied through by that 14. I did this knowing that it was going to simplify out in such a manner that we only had integers. So even though some of these numbers look a little large, we should feel confident that all of these are going to divide out pretty nicely. And again, if you need to use a calculator to check, that's perfectly fine. But starting with this 42 over 14, I see that that actually simplifies down to just 3. 14 over 7 just becomes 2, so that's 2x. 70 over 2 is just 35, or 35x. The 350 over 14 is just the 25. I'm going to start rewriting that again just because I can see I'm going to run out of room here. But again, if I give myself a little bit more space here, that first term ended up being 3 minus 2x minus 35x. The 350 over 14, if we reach for a calculator, we can see that that actually just divides down to 25. And then the 126 over 14 just becomes a 9. And so now I can just simplify by combining our like terms. I see a negative 2x and negative 35x becomes a negative 37x. So see how I'm combining terms first that contain variables. Now I'm looking for terms on the left-hand side that don't contain variables, 3 and negative 25. So I can combine that into a negative 22. And one thing I want to emphasize is that when I combine those terms, they were all on the left side of the equation, which is why I could simply combine them without worrying about adding or subtracting to both sides of the equation. And we do see that this is still equal to 9. So now I need to apply inverse operations. Reverse order of operations tells me that the subtraction of 22 is the first thing I have to deal with. So I'm going to add 22 to both sides. This is going to leave me with negative 37x equal to 9 plus 22, which is 31. And then if I divide by that negative 37, again I'm dividing because that's the inverse of multiplication, which I see between the 37 and the x, I can see that my final solution is just going to be x equals negative 31 over 37. Last example I'd like to do with you is slightly different. I noticed I actually have 3 fractions, but it's a little tricky because I actually have these entire expressions with variables and non-variable terms in the numerator here. But what I want to emphasize is that this really isn't much different. I still just want to focus on the fact that I have some fractions and I want to get rid of those fractions. So really I just have 3 denominators here. I have 3, I have 4, and I have 6, and I know that all 3 of these numbers can multiply to 12. That's our least common multiple. So I'm going to go ahead and multiply both sides of this equation by 12. So first the left-hand side, and again I'm putting up the brackets or the parentheses to remind me to distribute. And I'm also going to multiply the right side by 12. So first, if I distribute through on the left-hand side, this is going to give me 24x plus 60. And I want to emphasize, I'm distributing that 12 not only to the first term, but to the second term, both terms on the top of this first fraction that's over 3. And then same thing here, to both terms above the 4. So that's minus 36x minus 12 over 4. And that's going to equal 12 times the 7, which is 84 over 6. Now, a key thing to recognize here is that the 3 is dividing both things here. 3 is dividing 24x, and 3 is also dividing 60. So 24 and 60 are both divisible by 3, and this is by design. I do have to divide both values there by the 3 since they're both being on the top of that same fraction, but they're both being affected by that denominator. So 24 divided by 3, that's going to give me an 8x. So 8x plus 60 over 3 is 20. Now here's where we have to be a little tricky. I told you earlier that when we have an entire expression on top of a fraction, there's almost like an implied set of parentheses on the top here. Right? And that may make sense because that would kind of reinforce why we had to distribute to both those terms, or we have to distribute across the parentheses. So as I divide here, I even want to keep those parentheses up. So I want parentheses around the 8x plus 20, and I also want to keep those parentheses around as I then do 36 divided by 4, which is 9x, and then negative 12 divided by 4, which is a negative 3. And then finally the 84 divided by 6, which ends up being 14. Now those parentheses are very important. The first one, it doesn't make much of a difference because nothing's really happening to those. But because I'm subtracting, here's this key term, this subtraction right here, the 9x and the 3, I'm subtracting both of those terms. So first, minus a positive 9x is just negative 9x. But if I subtract a negative 3, so again, if I subtract a negative 3, that double negative actually means I'm adding 3, which is a little tricky here, and I end up with a positive 3. Okay, so now we can combine our like terms, 8x and negative 9x. Notice how these are both on the left-hand side of the equation. I can just combine those into a negative x. 20 and 3 are also on the same side of the equation. I can just combine those into a 23. This is equal to 14. So now we just have to finish the equation. I'll rewrite it up here. Negative x plus 23 equals 14. I can notice, well, I have this 23. That's the addition I have to deal with first. So I'm going to do the inverse of addition, which is subtraction. And notice how I'm doing this to both sides of the equation. That's going to leave me with a negative x equal to a negative 9. And technically, this little negative I have in front is really multiplication by a negative 1. And the inverse of multiplication is division. So I'm going to divide by that negative 1 on both sides, giving me the final solution, x equals 9. Okay, so at this point we've gone through 4 examples. I'd like you to try the last 4 examples on your own, and we'll check in on these next class.